Okay, so round two, let's try this again. So this is going to be the part one of what I believe is going to be what we need to do for module two, for chapter two notes, day two. So this part's just going to mostly cover atomic mass. So atomic mass. This is going to sound a lot familiar to you. It might be a little bit confusing because it has pretty much the same definition as mass number. So this is the total weight of protons and neutrons. Okay? Usually because when we actually talk about protons and neutrons, they actually have about 10 to the negative 27th kilograms of mass. So when we talk about these atomic mass, it's not going to necessarily be in a whole number like we did with mass number. And that's what makes it different. Okay, so that's the first concept that we're going to talk about with atomic mass. The other thing that we're going to talk about is atomic mass units, or AMUs. Okay, so what is this? Well, this is just the unit that we use for atomic mass. So the formal definition is unit used to express the relative masses of atoms and subatomic particles that is exactly 1/2 the mass of a carbon-12 molecule with six protons and six neutrons in its nucleus. Very long, very annoying. I'm not going to make you write all that down. It is posted with the notes that I posted yesterday, so hopefully you'll have reviewed them and this will be a little bit better of an explanation. So, if, in theory, if we had nitrogen 14, it would have around 14 AMU. Okay? So that's just the number that we'll use to, the unit that we use to express atomic mass. We're going to use it a lot, and we're going to explain how that connects to other things, because when we're going to be talking about atomic mass from now on, we're going to be talking about what is known as the average atomic mass, which is what is found in your periodic table. So the final thing we need to talk about when it comes to this, we know that there's a bunch of different isotopes, right? We learned how to write them, we learned what they mean, we learned all of that in last week. Now we're going to talk about why we have so many of those and how does that play into what we find on the periodic table. So, natural abundance. So this is kind of a little bit self-explanatory. If you really think about what the word natural means, it comes from nature, and abundance, amount, right? So this is really just the amount of a certain isotope that's found in nature. The formal definition is the proportion of a particular isotope expressed as a percent relative to all other isotopes of that element. Okay? So that means that essentially it's just a percentage of what is found in the environment. All of the isotopes that we're going to talk about when we determine the average atomic mass are going to be naturally occurring isotopes. We won't be having to deal with any man-made isotopes. I won't have you do that. It does exist. I'm not going to say that it doesn't. However, that's not something you need to be concerned with. So, neon has 3 different isotopes. Okay? And these are 3 different naturally occurring isotopes. Neon 20, neon 21, and neon 22. Okay? Now, the mass of these, the atomic mass in AMU, is going to be 19.9924 for neon 20. And as you can see, if you rounded that off to a whole number, you are going to get 20, right? 9 rounds up, you get 20. But it's a little bit less, and that's just because of the difference when it comes to weighing out the actual mass of a proton or a neutron. Okay? Next one is for neon 21 is going to be 20.9940. Okay? And then for neon 22, it is going to be 21.9914. Okay? So that's our mass. That's our atomic mass that we're going to be finding for this. We're going to talk about the natural abundance for each of these. And this will be expressed as a percent. Okay? So, the first one's going to be 90.4838%. Okay? Next one, 0.2696%. It's not really found that much. Very small amount of that is found in the environment. The majority is going to be neon 20. And we'll see that when we get closer. They'll see that our average atomic mass will be closer to neon 20, which I'll explain why that occurs in a minute. And then the final one's going to be 9.2465%. Okay? And that should add up to about 100%. That's what we should get for the answer. And if so, way that all of our natural abundances come out evenly to 100%. Okay? So, giving you all this information. And now, the big finale of this whole thing. I'm going to give you the average, essentially the equation that you're going to be using that you have this information for to solve for the average atomic mass. So average atomic mass equals x1 over 100 times m1 plus x2 over 100 times m2 plus dot 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 xn over 100 times nm. Okay, where x is our percentage of natural abundance, and m is going to be our atomic mass for each isotope. And that'll be an AMU. Okay? So, this can go on for more than 3. For neon, it's only going to be 3, but for platinum, it'll be 6. For another one, it could be 8. It could be 10, it could be 20, it could be a million. You know, we don't really know. I don't really think we're ever going to see more than 5, other than the platinum that I'm going to do in a minute here. You're not going to see much more than 5, so I wouldn't worry too much about it. But the idea is we put the xn to state for that number of how many isotopes we have. So just continue on until you get to the number of isotopes and then add them all up together. So, if I was going to do this for neon, given the information that you saw previously, I would do it as such. I put 90.4838% 0.4838 all over 100 times 19.9924 plus 0.2696 times 100, or sorry, over 100 times 20.9940. Okay, plus 9.2465 all over 100 times 21.9914. Okay? So this should all be on the same line for you guys, but unfortunately I write big and this doesn't really fit very well on my nice little whiteboard here. So it should all be on one line. And you should add those all up together. This is where it's good to have a scientific calculator because it's going to be a little bit difficult to multiply all those together and then add them up. But essentially that's what you're going to do. You're going to divide this, turn it into a decimal, and multiply it by whatever the atomic mass is. Add those all up together and that should give you your average atomic mass. And that's what you're going to find in your periodic table. So this is going to round out. This is going to come out to 20.1799 AMU. So, and if you checked your periodic table, which you should have out while we are doing this section, really you should have it out for every single class. But if you have it out during this section, if you check the periodic table, it should come up to 20.180, and that's just rounded off. Differences between periodic tables. You'll see it extended out more for certain periodic tables. The one in our book rounds off to about 3 decimal places. So that's where the difference comes in. Okay? So, next type of problem you might see. Platinum has 6 isotopes. It's going to be 190 platinum. Platinum 192. 194. 195, 196, and 198. So their mass. Okay, the mass is going to be 189.96, 191.96, 193.96, 194.97, 195.97, and 197.97. Okay? That's what we averaged it out to, number of information that I've been given. So I will always give you enough information to solve any of these problems. So we're going to talk about different ways that we can do that, but I will always give you the information. So don't worry about that. Next is going to be natural abundance. So for the first one, we're going to get 0.014%. Not a whole lot. Still naturally exists. It's got enough to have significance, so we should add it. Next one's 0.782. Again, not so much in the environment. Just how it is. Next is going to be 32.967. Okay? Following is going to be 33.832. 25.242. And 7.163. Okay? So that's our information that we're given. Now, what am I going to do with this? Well, the only thing I don't know from this whole thing is going to be the average atomic mass. And so that's usually what the question will ask. They'll say, find the average atomic mass. So using this information, I am going to do just that. So I'm going to write my equation. So I'll start by writing my average atomic mass. And then I will write, don't really need to write x sub 1 over 100 times m sub times m sub 1. That doesn't really matter. What I want you to do is plug the information in, knowing your equation. Okay? So 0.014 all over 100 times 189.96 plus 0.782 all over 100 times 191.96 plus 32.967 all over 100 times 193.96 plus 33.832 all over 100 times 194.97 plus 25.242 all over 100 times 195.97 plus 7.163 all over 100 times 197.97. Okay? So I've plugged all my information in. You make sure that your corresponding natural abundance matches up with your correct atomic mass. Once you've done that, you should multiply it out. And you should get some answer for your average atomic mass. For this one, it's going to equal 195.08 AMU. Once I have this information, I should go back to my periodic table and check to make sure that my numbers match up. Because I already know what it is, right? I told you, it's platinum. So if I go and check my platinum on my periodic table, it should be around 195.08 AMU. If I find that, it's going to be right below the element name. That's going to be where you find your average atomic mass. That's going to be where I check my answer. If I don't get that, then I need to check my math. I need to check to make sure that I plugged everything in correctly, that the percentages match up with the correct atomic mass. If I don't have those things, then I'm still getting the wrong answer somehow, then I got to check how I'm putting it into my calculator. If you need help putting it into your calculator, please come talk to me. Those are the things that we need to do to make sure that we get the correct answer on this, because I can't help you on the test, but I can help you until then. So, the other way that I may ask another question is I may go something similar like this. So silver has 2 stable isotopes. Okay, so silver has other isotopes, but the only ones that are stable are the ones that we're concerned with. They're stable and naturally occurring, so that's the ones we're concerned with. If they're not stable, we can't really measure them, so kind of is a stated thing, but sometimes we'll write it that way as well. So 107 Ag, 106.90 AMU. And 109 Ag, so with 108.90 AMU. Okay? The natural abundances. Of these isotopes are as follows. So 51.5% and 48.5% respectively. So when I say respectively, that means that the first number goes with the first number I mentioned. The second number goes with the second number I mentioned. You'll see respectively a lot when we deal with this class. Okay? So, what is the average atomic mass? Okay? So that's something that could show up on my test or my quiz. I guarantee it's probably going to show up on the quiz at least. And so what you're going to have to do here is take the information and dissect it. So I'm going to put it into my equation. So I write out my average atomic mass is equal to 51.5 all over 100 times, what was that first, remember that first atomic mass that I discussed? It was 106.90 plus 48.5 all over 100 times 108.90. Okay? Pretty simple. Just making sure that we're lining things up correctly. So, first goes with the first, second goes with the second. And when I multiply this out, I should get 107.87 AMU. Now what do? I go check my periodic table because I already know what my element is. I told you it was silver. So I'm going to go check for silver and see that yes, that is correct. So I'm good. If I don't get that answer, if I don't match up, then I've done something wrong with my math and I need to reevaluate and check my numbers. So it could be that I switched my percentages. Oops, that's okay. That's why you check your periodic table. You're going to have your periodic table on the test. Why not use it to your advantage? Okay? So another question that could show up would be an element has two stable isotopes. Okay, so one has 62.9298 AMU. The second has 64.9278 AMU. The first natural abundance is going to be 69.09%. The second is going to be 30.91%. Okay? So I'm taking it a step further. I haven't told you the element this time. So I'm gonna ask you, what is the element and average atomic mass? Okay, well, didn't tell you the element, but I told you the other information that you need. So what you're going to do is you're going to plug it into your equation, because we always want to start by plugging things into our equation. So average atomic mass, and that's going to equal 69.09 all over 100 times 62.9298 plus 30.91 all over 100 times 64.9278. Okay? So, those two. That's all we gotta do. Now we just plug and chug, right? So we're just going to multiply this out in our calculator. And when I do that, I should get 63.547 AMU. Okay? So from there, I'm going to go back to my periodic table, which is my best friend for this class, right? So I'm going to go back to my periodic table, and I'm going to check my answer to see which one has that. Well, when I do that, I'm going to get copper. Okay? So, if I don't find an element that matches up with my AMUs, my average atomic mass, then I did something wrong with my math. So what do? I go back and I check to make sure that all my percentages match up correctly. and that my numbers are all correct, and that I entered everything incorrectly into my calculator. And then maybe I get a different answer, it matches up correctly, and I find copper again. Okay? So that's the whole point of that, is to make sure that we're using our periodic table as our check. So, and then we can find out what the element is. Okay. I'm going to stop this lesson here, and then I will re-record another one and post that one after this. So, stay tuned, guys.